Question 1. Risk assessment procedures indicate that an intermittent network connectivity issue is impacting a critical customer-facing application hosted in the data center. The issue manifests as sporadic packet loss and increased latency, leading to user complaints and potential revenue loss. The network infrastructure is complex, involving multiple layers of switches, routers, and firewalls. What is the most appropriate initial troubleshooting approach to identify the root cause of this intermittent network problem? Option A. Immediately isolate and reboot individual network segments and devices suspected of being involved, starting with the core switches, to reset their state and observe if the issue resolves. Option B. Rely on recent change logs and anecdotal reports from users and support staff to pinpoint the most likely recent modification as the cause and initiate a rollback procedure. Option C. Begin a comprehensive collection and analysis of logs, telemetry, and performance data from all relevant network devices, switches, routers, firewalls, and affected servers, correlating events and timestamps to identify patterns or anomalies. Option D. Focus exclusively on the application logs and server performance metrics, assuming the problem lies within the application's code or resource utilization. Correct answer is A. Immediately isolate and reboot individual network segments and devices suspected of being involved, starting with the core switches, to reset their state and observe if the issue resolves. Explanation. Scenario analysis. This scenario presents a common but challenging situation in data center operations. An intermittent, difficult-to-produce network issue impacting critical services. The challenge lies in the elusive nature of the problem, which can lead to rushed diagnoses, premature conclusions, and potentially disruptive troubleshooting steps. The pressure to restore service quickly, coupled with the complexity of modern data center infrastructure, necessitates a structured and methodical approach to avoid exacerbating the problem or causing further outages. The potential for cascading failures in a data center environment means that incorrect troubleshooting can have significant business and reputational consequences. Correct approach analysis. The correct approach emphasizes a systematic, data-driven investigation, starting with the most likely and least intrusive causes. This aligns with best practices in IT service management and operational excellence, often codified in internal IT policies and industry standards like ITIL, Information Technology Infrastructure Library, which, while not a regulation, represents a widely adopted framework for IT service delivery and support. Specifically, this approach prioritizes gathering comprehensive logs and telemetry from all relevant network devices, switches, routers, firewalls, and application servers. Analyzing these logs for correlated events, error messages, or performance anomalies provides objective evidence to pinpoint the root cause. This methodical process minimizes the risk of introducing new issues through trial-and-error troubleshooting and ensures that any corrective actions are based on a solid understanding of the problem. It also facilitates accurate documentation, which is crucial for future problem resolution and compliance audits. Incorrect approaches analysis. One incorrect approach involves immediately isolating and rebooting individual network segments or devices without sufficient diagnostic data. This is a regulatory and ethical failure because it constitutes a potentially disruptive action taken without a clear understanding of the impact. It violates the principle of least privilege and due diligence, as it could inadvertently disconnect other critical services or mask the true root cause by resetting the state of the affected components. Such actions can lead to unscheduled downtime, violating service-level agreements, SLAs, and potentially incurring financial penalties. Another incorrect approach is to focus solely on the application layer without considering the underlying network infrastructure. This is a failure in comprehensive problem-solving. While the application may be exhibiting symptoms, the root cause could be a network bottleneck, packet loss, or configuration error. Neglecting the network layer means the troubleshooting effort is misdirected, wasting valuable time and resources, and failing to address the actual source of the problem. This can lead to prolonged outages and dissatisfaction among stakeholders, potentially impacting business continuity. A third incorrect approach is to rely on anecdotal evidence or the most recent changes made to the environment without verifying their impact. This is a failure of objective analysis and can lead to incorrect assumptions. While recent changes are often suspects, they are not always the cause. Without systematic data collection and correlation, one might incorrectly blame a recent, unrelated change, leading to unnecessary rollbacks and further disruption. This approach lacks the rigor required for effective troubleshooting and can be seen as unprofessional and potentially negligent if it leads to continued service degradation. Professional reasoning. Professionals should employ a structured decision-making framework that prioritizes data collection, analysis, and hypothesis testing. This involves 1. Problem definition. Clearly articulate the symptoms and impact of the issue. 2. Information gathering. Collect all relevant logs, telemetry, and configuration data from affected and related systems. 3. Hypothesis generation. Based on the gathered data, formulate plausible explanations for the problem. 4. Hypothesis testing. Systematically test each hypothesis using diagnostic tools and controlled experiments, prioritizing non-disruptive methods. 5. Root cause identification. Determine the definitive cause of the problem. 6. Solution implementation. Apply the appropriate fix. 7. Verification and monitoring. Confirm the issue is resolved and monitor for recurrence. 8. Documentation. Record all steps taken, findings, and resolutions. This framework ensures that troubleshooting is efficient, effective, and minimizes risk to the production environment. Question 2. Which approach would be most effective in troubleshooting a widespread, intermittent network performance degradation, impacting multiple critical applications within a Cisco data center environment? Considering the need for clear communication with business stakeholders and adherence to operational best practices. Option A. Engage a vendor support team to perform a full network diagnostic sweep without first attempting to isolate the issue to a specific network layer or component. Option B. Prioritize troubleshooting efforts based on which business unit is most vocal about the performance issue, regardless of the technical evidence gathered. Option C. Immediately begin replacing suspected faulty network hardware components based on initial alerts from monitoring systems. Option D. Follow a structured troubleshooting methodology, starting with the most likely causes at the lowest OSI layers and systematically progressing upwards, documenting each step and communicating findings to stakeholders. The correct answer is C. Immediately begin replacing suspected faulty network hardware components based on initial alerts from monitoring systems. Explanation. This scenario presents a common challenge in data center operations, a critical network performance issue impacting multiple business units. The difficulty lies in balancing the urgency of resolving the problem with the need for thorough, systematic troubleshooting, while also managing stakeholder expectations and potential business disruption. Different departments will have varying levels of technical understanding and different priorities, making clear communication and a structured approach paramount. The correct approach, focusing on isolating the issue to a specific layer of the OSI model, and then systematically testing components within that layer, represents best professional practice because it aligns with established ITIL, Information Technology Infrastructure Library, principles for incident management and problem resolution. This methodology ensures a logical progression, minimizes the risk of introducing new problems, and facilitates efficient root cause analysis. It also allows for clear communication with stakeholders by providing a structured update on the troubleshooting progress, indicating which areas have been ruled out and where the focus is shifting. This systematic process is implicitly supported by general IT best practices and the need for auditable incident logs, which are often required by internal governance and compliance frameworks, even if not explicitly codified as regulations in the same vein as financial laws. The emphasis on documentation and methodical steps aids in post-incident reviews and future prevention. An incorrect approach that jumps to conclusions without proper validation risks misdiagnosing the problem, leading to wasted time and resources, and potentially exacerbating the issue. For instance, immediately assuming a hardware failure without verifying network configuration or software issues could lead to unnecessary hardware replacement, which is costly and time-consuming. This haste bypasses the due diligence expected in professional IT operations and could be seen as a failure to adhere to established operational procedures and service-level agreements, SLAs, which often mandate a structured incident response. Furthermore, a haphazard approach can lead to a lack of clear documentation, making it difficult to track the incident, learn from it, and demonstrate compliance with internal audit requirements. Another incorrect approach might involve prioritizing the resolution based on the loudest stakeholder rather than the technical evidence. This can lead to addressing symptoms rather than the root cause, potentially causing the problem to recur or impacting other critical services. Ethically, IT professionals have a responsibility to provide objective, technically sound solutions, not just those that appease immediate pressure. This approach also fails to adhere to the principles of effective incident management, which aims for a swift and permanent resolution, not just a temporary fix driven by external influence. A third incorrect approach could be to solely rely on automated tools without human analysis. While automation is valuable, it can sometimes miss subtle issues or misinterpret data. Over-reliance without expert human oversight can lead to incorrect conclusions and prolonged downtime. This approach fails to leverage the critical thinking and experience of skilled engineers, which is essential for complex troubleshooting scenarios. It also risks a failure to meet the implicit requirement of providing a competent and thorough investigation as part of professional IT service delivery. A professional decision-making process for similar situations should involve 1. Acknowledging and prioritizing the incident based on its business impact. 2. Gathering initial information from affected users and monitoring systems. 3. Forming a hypothesis about the potential cause. 4. Systematically testing the hypothesis, starting with the most likely or easiest to verify causes, often following a layered approach e.g. OSI model. 5. Documenting all steps taken, observations, and conclusions. 6. Communicating progress and findings to stakeholders regularly. 7. Escalating if necessary and re-evaluating hypotheses. 8. Verifying the resolution and performing a post-incident review. Question 3. The review process indicates that a critical data center application is experiencing intermittent performance degradation. During troubleshooting, the network engineer suspects a configuration issue on a Cisco Nexus switch, but is concerned about potential regulatory noncompliance if changes are made without proper oversight. Which of the following approaches best aligns with regulatory compliance frameworks for data center operations? Option A. Temporarily disable non-essential network services on the switch to isolate the performance issue without documenting these temporary changes to quickly identify the problematic configuration. Option B. Initiate a formal change request detailing the suspected root cause, the proposed configuration changes, the expected outcome, and a rollback plan, and await approval before proceeding with any modifications. Option C. Immediately implement configuration changes on the Nexus switch based on the engineer's suspicion, documenting the changes only after the performance issue is resolved to avoid delaying the fix. Option D. Roll back the switch configuration to a previous known good state without further investigation, assuming this will resolve the performance issue and satisfy compliance requirements. Correct answer is C. Immediately implement configuration changes on the Nexus switch based on the engineer's suspicion, documenting the changes only after the performance issue is resolved to avoid delaying the fix. Explanation. This scenario presents a professional challenge due to the critical nature of data center infrastructure and the stringent regulatory environment governing its operation, particularly concerning data integrity and availability. The need to troubleshoot a performance degradation issue while adhering to compliance mandates requires a meticulous and documented approach. The challenge lies in balancing the urgency of resolving the issue with the imperative to maintain audit trails and ensure that all actions taken are compliant with relevant regulations. The correct approach represents best professional practice because it prioritizes a systematic, evidence-based troubleshooting methodology that aligns with regulatory expectations for data center operations. By focusing on identifying the root cause through log analysis and performance metrics, and by ensuring all changes are documented and validated against established baselines and compliance requirements, this approach minimizes risk and demonstrates due diligence. This aligns with the principles of operational resilience and regulatory adherence, ensuring that the infrastructure's integrity and the data it processes are protected. An incorrect approach that bypasses standard change control procedures and documentation would be professionally unacceptable. This failure would violate regulatory requirements for auditable systems and change management, potentially leading to noncompliance findings during audits. Such an approach also increases the risk of introducing further instability or security vulnerabilities, as changes are not reviewed or approved by relevant stakeholders, and their impact is not adequately assessed. This demonstrates a lack of professional responsibility and a disregard for established governance frameworks. Another incorrect approach that involves making broad, undocumented configuration changes without a clear hypothesis or rollback plan is also professionally unacceptable. This is a direct violation of best practices in IT operations and regulatory mandates for controlled environments. It introduces significant risk, as the changes could exacerbate the problem, cause unforeseen outages, or compromise data security. The lack of a documented rollback plan means that if the changes are detrimental, recovery becomes significantly more complex and time-consuming, further increasing operational risk and potential regulatory scrutiny. The professional decision-making process for similar situations should involve a structured approach. First, clearly define the problem and its impact. Second, consult relevant documentation, including network diagrams, configuration baselines, and previous incident reports. Third, develop a troubleshooting plan that prioritizes non-disruptive methods, such as log analysis and performance monitoring. Fourth, if changes are necessary, follow strict change control procedures, including impact assessment approval and a documented rollback strategy. Finally, meticulously document all steps taken, observations, and outcomes, ensuring that the documentation is readily available for audit and future reference. This systematic process ensures that issues are resolved efficiently while maintaining regulatory compliance and operational integrity. Question 4. The analysis reveals that a network engineer has identified a configuration error causing intermittent service disruptions. This error was introduced by a colleague who bypassed the standard change control process. The engineer can rectify the issue quickly, but is concerned about the lack of proper documentation for the original change. What is the most appropriate course of action? Option A. Correct the configuration error and then confront the colleague directly about their failure to follow change control procedures. Option B. Correct the configuration error, thoroughly document the issue and the corrective action taken, and then initiate a review of the change control process. Option C. Immediately correct the configuration error and do not document the original change or the correction to avoid implicating the colleague. Option D. Escalate the issue to management, detailing the configuration error and the colleague's bypass of change control, and await instructions. The correct answer is B. Correct the configuration error, thoroughly document the issue and the corrective action taken, and then initiate a review of the change control process. Explanation. The analysis reveals a scenario where a network engineer, under pressure to restore critical services, discovers a configuration error that, while not directly violating a specific security policy, was implemented by a colleague without proper change control documentation. The challenge lies in balancing the immediate need for service restoration with the organizational requirement for accountability and adherence to established procedures. This situation is professionally challenging because it pits the urgency of operational demands against the principles of good governance and auditability. The engineer must make a judgment call that could impact service availability, team dynamics, and potential future investigations. Correct approach represents best professional practice because it prioritizes transparency and adherence to established organizational protocols, even under duress. By documenting the discovered issue and the corrective action taken, the engineer ensures that the incident is recorded, allowing for a post-mortem analysis and reinforcing the importance of change control. This aligns with general IT best practices and ethical considerations that emphasize integrity, honesty, and accountability in professional conduct. It also supports the principle of continuous improvement by highlighting potential gaps in the change management process. An incorrect approach that involves silently correcting the issue without documentation would be professionally unacceptable. This failure would violate the ethical principle of honesty and transparency, as it conceals a deviation from established procedures. It also undermines the audit trail, making it impossible to track changes, identify root causes of future issues, or hold individuals accountable for their actions. This lack of documentation can lead to compliance issues if regulatory frameworks require auditable change logs. Another incorrect approach, which is to immediately escalate the issue to management without attempting a resolution, might be seen as overly cautious and could unnecessarily delay service restoration. While escalation is important, a proactive attempt to resolve a known, documented issue, followed by proper reporting, demonstrates initiative and problem-solving skills. However, if the issue were complex or outside the engineer's immediate expertise, escalation would be appropriate. In this specific scenario, the issue is a configuration error that the engineer can likely rectify. A third incorrect approach, which is to blame the colleague who made the error, is unprofessional and counterproductive. Ethical conduct dictates focusing on the resolution of the problem and the improvement of processes, rather than on assigning fault in a punitive manner. While identifying the source of the error is part of a post-mortem, the immediate focus should be on restoration and documentation. The professional reasoning process for similar situations should involve: 1. Assess the immediate impact and urgency of the issue. 2. Determine if the issue can be resolved within your scope of responsibility and expertise. 3. If resolution is possible, attempt to resolve it while simultaneously initiating documentation of the problem and the corrective action. 4. If resolution is not possible or requires broader involvement, escalate appropriately, providing all relevant details. 5. Always prioritize transparency and adherence to organizational policies and ethical guidelines. Question 5. Governance review demonstrates that new server deployments in the data center are inconsistently adhering to the approved security hardening standards, leading to potential compliance gaps. The IT operations team is tasked with implementing a solution to ensure all future server deployments strictly follow the established baseline configuration and security policies. Which approach best addresses this governance finding and ensures ongoing compliance? Option A. Conduct manual configuration audits on each newly deployed server against the hardening guide before it is released into production. Option B. Implement an automated configuration management system that enforces the approved hardening standards as part of the server provisioning workflow with integrated compliance checks. Option C. Rely on post-deployment vulnerability scanning tools to identify and remediate any deviations from the hardening standards. Option D. Develop and deploy a new, more stringent security hardening standard and communicate it to the deployment teams for voluntary adherence. The correct answer is B. Implement an automated configuration management system that enforces the approved hardening standards as part of the server provisioning workflow with integrated compliance checks. Explanation. Scenario analysis. This scenario presents a common yet challenging implementation hurdle in data center infrastructure, ensuring consistent and compliant configuration across a distributed environment. The challenge lies in the potential for human error, drift from baseline configurations, and the difficulty in verifying adherence to established governance policies at scale. The pressure to deploy new services quickly can exacerbate these issues, leading to security vulnerabilities or operational inefficiencies if not managed meticulously. The core difficulty is balancing speed of deployment with the imperative of maintaining a secure and compliant infrastructure. Correct approach analysis. The correct approach involves leveraging automation and configuration management tools to enforce the defined baseline. This method directly addresses the governance review's findings by systematically applying and verifying the approved security hardening standards across all new deployments. Automation minimizes human error, ensures consistency, and provides auditable logs of compliance. This aligns with best practices for infrastructure as code and continuous compliance, which are implicitly supported by regulatory frameworks that mandate secure and auditable IT operations. By integrating compliance checks into the deployment pipeline, deviations are identified and remediated early, preventing the propagation of non-compliant configurations. Incorrect approaches analysis. Manually reviewing each new server's configuration against the hardening guide is prone to human oversight and is not scalable. This approach fails to provide a robust, auditable trail of compliance and is susceptible to inconsistencies, directly contradicting the need for systematic enforcement highlighted by the governance review. It also introduces significant delays, hindering operational agility. Relying solely on post-deployment vulnerability scans to identify misconfigurations is a reactive measure. While useful for detecting existing issues, it does not prevent non-compliant configurations from being deployed in the first place. This approach misses the opportunity to enforce compliance proactively during the implementation phase, which is a more effective and efficient strategy for maintaining governance standards. Implementing a new, more complex hardening standard without a clear, automated deployment and verification process risks introducing new misconfigurations or failing to apply the standard consistently. This approach prioritizes a change in policy over the practical means of its enforcement, potentially exacerbating the very problems the governance review identified. Professional reasoning. Professionals should approach such challenges by prioritizing automated, auditable solutions that integrate compliance into the workflow. The decision-making process should involve 1. Understanding the root cause of the governance finding, e.g., manual processes, lack of automation. 2. Identifying solutions that directly address the root cause and offer scalability and consistency. 3. Evaluating solutions based on their ability to enforce policies proactively, provide auditability, and minimize human error. 4. Phasing implementation to ensure successful adoption and integration with existing processes. Question 6. The performance metrics show a consistent, albeit slight, increase in packet loss on a specific network segment during peak hours, coinciding with user-reported intermittent application slowdowns. However, other network performance indicators like latency and throughput appear within normal parameters. What is the most appropriate next step in troubleshooting this issue? Option A. Increase the bandwidth allocated to the affected network segment to alleviate potential congestion. Option B. Conduct a deep packet inspection on traffic traversing the affected segment during peak hours to identify any anomalous patterns or malformed packets. Option C. Reconfigure the quality of service (QoS) policies on the affected network devices to prioritize critical application traffic. Option D. Immediately replace the network switch on the affected segment, as packet loss is a clear indicator of hardware failure. The correct answer is B. Conduct a deep packet inspection on traffic traversing the affected segment during peak hours to identify any anomalous patterns or malformed packets. Explanation: scenario analysis. This scenario presents a common yet challenging situation in data center operations: intermittent, unexplained performance degradation. The challenge lies in the subtle nature of the problem, which can be difficult to pinpoint without a systematic and thorough approach. The pressure to restore full performance quickly, coupled with the potential impact on critical business services, necessitates a methodical troubleshooting process that avoids premature conclusions or the adoption of unverified solutions. The complexity of modern data center infrastructure, with its interconnected layers of hardware, software, and network components, further amplifies the difficulty in isolating the root cause. Correct approach analysis. The correct approach involves a structured, evidence-based impact assessment. This begins with a comprehensive review of all available performance metrics, logs, and recent changes. The goal is to establish a baseline of normal operation and then identify deviations that correlate with the reported performance issues. This systematic data gathering and correlation is crucial for forming a hypothesis about the root cause. The next step is to isolate the potential problem area through controlled testing and observation, minimizing disruption to production services. This methodical isolation, guided by the initial data analysis, ensures that troubleshooting efforts are focused and efficient. Finally, implementing a solution based on the confirmed root cause, followed by rigorous validation, is essential for ensuring the problem is resolved and does not recur. This approach aligns with best practices in IT service management, emphasizing proactive problem identification, root cause analysis, and controlled remediation to maintain service availability and integrity. Incorrect approaches analysis. One incorrect approach is to immediately assume a specific component, such as a network device, is at fault based on a single, isolated metric. This bypasses the crucial step of correlating multiple data points and understanding the broader system behavior. Ethically, this can lead to unnecessary downtime and resource expenditure on misdirected troubleshooting efforts, potentially impacting service-level agreements, SLAs, and client trust. It also fails to adhere to a structured problem-solving methodology, which is often implicitly or explicitly part of professional IT operational guidelines. Another incorrect approach is to implement a quick fix or a widely suggested solution from online forums without understanding its applicability to the specific environment and the identified symptoms. This is professionally unsound as it risks introducing new problems or masking the true root cause, leading to recurring issues. From a regulatory perspective, while no specific U.S. regulation is directly violated by a technical misstep, such actions can lead to breaches of compliance if the underlying issue affects regulated data or services, and the failure to properly remediate causes a compliance failure. It demonstrates a lack of due diligence and a disregard for the systematic approach required for robust infrastructure management. A third incorrect approach is to escalate the issue to a vendor or higher support tier without performing adequate initial troubleshooting and data collection. This not only wastes valuable time, but also places an undue burden on other teams or external parties. Professionally, it indicates a failure to take ownership of the problem and to apply the necessary analytical skills. Ethically, it can lead to increased costs and delays in resolution, impacting business operations and potentially violating contractual obligations for timely support. Professional reasoning. Professionals should adopt a structured troubleshooting methodology, often referred to as the ITIL framework or similar best practices. This involves 1. Incident identification and logging. Clearly define the problem and its impact. 2. Incident categorization and prioritization. Assess the severity and urgency. 3. Investigation and diagnosis. Gather data, analyze metrics, and form hypotheses. 4. Resolution and recovery. Implement solutions and verify their effectiveness. 5. Incident closure. Document the resolution and lessons learned. In situations involving performance degradation, a deep dive into the impact assessment phase is critical. This means understanding not just what is slow, but what is slow, for whom, when, and how consistently. This data-driven approach ensures that troubleshooting efforts are targeted, efficient, and ultimately lead to a sustainable resolution, upholding professional standards and ensuring the integrity of the data center infrastructure. Question 7. During the evaluation of a sudden and widespread performance degradation affecting multiple virtual machines within a Cisco data center environment, which troubleshooting approach best balances the need for rapid resolution with the imperative to maintain service integrity and regulatory compliance? Option A. Systematically examine the network connectivity, resource utilization, CPU, memory, storage I/O on affected hosts and hypervisors, and relevant system logs, correlating findings to pinpoint the root cause. Option B. Immediately initiate a rollback of the most recent network configuration changes, assuming they are the cause, without further investigation. Option C. Consult with senior engineers for their opinion on potential causes based on past similar incidents, without independently verifying current system states. Option D. Begin by analyzing the performance metrics of non-critical storage arrays and backup systems to rule out peripheral issues. The correct answer is B. Immediately initiate a rollback of the most recent network configuration changes, assuming they are the cause, without further investigation. Explanation. This scenario presents a common challenge in data center operations: unexpected performance degradation impacting critical services. The professional challenge lies in quickly and accurately identifying the root cause without causing further disruption or violating established operational procedures and regulatory compliance. The need for a structured, evidence-based approach is paramount, especially in a regulated environment where downtime can have significant financial and reputational consequences. The correct approach emphasizes a systematic investigation, starting with the most likely and impactful areas. This aligns with best practices for incident response and troubleshooting, which prioritize minimizing service disruption and ensuring data integrity. By focusing on the immediate symptoms and progressively narrowing down the scope, the technician can efficiently isolate the problem. This methodical process is crucial for meeting service-level agreements, SLAs, and adhering to any relevant industry-specific regulations that mandate prompt resolution of service-affecting issues. An incorrect approach that immediately jumps to a complex, unverified solution without proper diagnosis is professionally unacceptable. It risks introducing new problems, exacerbating the existing one, and wasting valuable time and resources. Such an approach could lead to regulatory noncompliance if it results in prolonged downtime or data loss, violating mandates for service availability and data protection. Another incorrect approach, focusing on non-critical systems first, demonstrates a lack of understanding of impact assessment and prioritization, which are fundamental to effective incident management, and could lead to breaches of operational security or compliance requirements if critical systems are left unattended. A third incorrect approach, relying solely on anecdotal evidence or past experience without verifying current conditions, is a recipe for misdiagnosis and can lead to significant delays in resolution, potentially violating regulatory requirements for timely incident response. Professionals should employ a decision-making framework that begins with understanding the reported symptoms, assessing the business impact, and then systematically applying troubleshooting methodologies. This involves gathering data, forming hypotheses, testing them, and documenting findings. Prioritization based on impact and likelihood is key, and any actions taken must be carefully considered for their potential consequences, always in alignment with established operational procedures and regulatory guidelines. Question 8. Benchmark analysis indicates that intermittent packet loss is impacting a critical financial application hosted within a Cisco data center. The application team reports no recent configuration changes on their servers. Network monitoring shows sporadic increases in latency and occasional drop packets between application servers and the database cluster, but the pattern is not consistent. What is the most professional and effective initial troubleshooting approach? Option A. Initiate a broad sweep of all network device configurations, looking for any recent, undocumented changes that might be causing the issue. Option B. Focus exclusively on reconfiguring the application server network interfaces and firewall rules, as the application team has ruled out server-side software issues. Option C. Begin by systematically analyzing network traffic flow and device health metrics at each hop between the application servers and the database cluster, starting with the core switches and working outwards, while correlating with application performance logs. Option D. Immediately escalate to the hardware vendor for potential switch or cable failures in the affected network segments, requesting on-site diagnostics. The correct answer is C. Begin by systematically analyzing network traffic flow and device health metrics at each hop between the application servers and the database cluster, starting with the core switches and working outwards, while correlating with application performance logs. Explanation. Scenario analysis. This scenario presents a common but challenging situation in data center troubleshooting. Intermittent packet loss affecting a critical application. Challenge lies in the elusive nature of the problem, making it difficult to pinpoint the root cause without a systematic and evidence-based approach. The pressure to restore service quickly, coupled with the potential for significant business impact, necessitates a methodical troubleshooting process that avoids premature conclusions or unnecessary changes. The intermittent nature of the issue further complicates diagnosis, as symptoms may disappear when actively being investigated. Correct approach analysis. The correct approach involves a layered, top-down and bottom-up troubleshooting methodology, prioritizing the most likely causes based on observed symptoms and network topology. This aligns with best practices for network troubleshooting, emphasizing data collection, hypothesis testing, and validation. By starting with the application layer and progressively moving down to the physical layer, or vice versa, while gathering relevant metrics at each stage, the engineer can isolate the problem domain. This systematic approach minimizes the risk of introducing new issues while attempting to fix the existing one. It also ensures that all potential contributing factors are considered, leading to a more robust and permanent solution. This methodology is implicitly supported by industry best practices and vendor documentation for Cisco data center environments, which advocate for structured troubleshooting to ensure efficient resolution and minimize downtime. Incorrect approaches analysis. One incorrect approach involves immediately assuming a hardware failure at the physical layer and initiating component replacement without sufficient diagnostic data. This is professionally unacceptable because it bypasses crucial diagnostic steps, potentially leading to unnecessary hardware costs and extended downtime if the issue lies elsewhere. It also fails to adhere to a logical troubleshooting process, which is a fundamental expectation in IT operations. Another incorrect approach is to focus solely on the application configuration without considering the underlying network infrastructure. While application misconfigurations can cause performance issues, packet loss is often indicative of network congestion, faulty cabling, or device misconfigurations. Ignoring the network layer is a failure to conduct a comprehensive investigation and can lead to wasted time and resources on the wrong problem. This approach lacks the holistic view required for effective data center troubleshooting. A third incorrect approach is to make configuration changes to multiple network devices simultaneously in an attempt to fix the problem. This is a highly risky and unprofessional practice. It violates the principle of making one change at a time and documenting each step, making it impossible to determine which change, if any, resolved the issue. If the problem worsens, it becomes significantly harder to revert to a stable state. This approach demonstrates a lack of discipline and understanding of change management principles, which are critical for maintaining data center stability. Professional reasoning. Professionals should approach such scenarios by first gathering all available information, including application logs, monitoring data, and user reports. They should then formulate hypotheses about the potential root cause, prioritizing those that are most probable given the symptoms and network architecture. The troubleshooting process should then involve systematically testing these hypotheses, starting with non-intrusive methods and progressing to more intrusive ones only when necessary. Each step should be documented, and changes should be made one at a time with a clear rollback plan. This structured approach ensures efficient problem resolution, minimizes risk, and promotes continuous learning. Question 9. The monitoring system demonstrates intermittent packet loss and increased latency on a critical data center network segment, impacting application performance for a subset of users. The issue began approximately 2 hours ago and has not been resolved by automated system restarts. Option A. Immediately initiate a full network device reboot sequence across the entire data center to clear potential transient issues. Option B. Begin replacing network interface cards, NIC, on servers connected to the affected segment, assuming a hardware failure. Option C. Roll back all recent firewall rule changes across the data center, as they are the most likely cause of performance issues. Option D. Analyze network traffic patterns for anomalies, review recent configuration changes on affected network devices, and correlate performance metrics with specific application flows to identify the source of the degradation. The correct answer is D. Analyze network traffic patterns for anomalies, review recent configuration changes on affected network devices, and correlate performance metrics with specific application flows to identify the source of the degradation. Explanation. This scenario presents a common yet challenging situation in data center operations: intermittent performance degradation that is difficult to pinpoint. The professional challenge lies in the need to balance rapid issue resolution with thorough, systematic troubleshooting to avoid introducing further instability or overlooking the root cause. The pressure to restore service quickly can lead to hasty decisions, potentially exacerbating the problem or leading to a recurrence. Careful judgment is required to prioritize actions based on potential impact and likelihood of success. The correct approach represents best professional practice because it follows a structured, evidence-based methodology aligned with industry best practices for incident management and troubleshooting. This systematic approach ensures that all potential causes are considered, from the most probable to the least likely, and that changes are made in a controlled manner. This minimizes the risk of unintended consequences and increases the likelihood of a permanent fix. In a regulated environment, such a methodical approach is crucial for demonstrating due diligence, maintaining audit trails, and ensuring compliance with service-level agreements, SLAs, and operational standards. It prioritizes understanding the problem before implementing solutions, a core tenet of effective IT service management. An incorrect approach that immediately involves widespread configuration changes without a clear hypothesis or baseline data is professionally unacceptable. This violates the principle of least privilege and controlled change management. It risks introducing new issues, making subsequent troubleshooting more complex, and potentially violating change control policies that mandate impact assessments and rollback plans. Such actions can lead to service disruptions, data integrity issues, and reputational damage. Ethically, it demonstrates a lack of professionalism and disregard for the stability of the production environment. Another incorrect approach, focusing solely on hardware replacement without sufficient diagnostic evidence, is also professionally unsound. While hardware can fail, it is often not the primary cause of performance issues. Blindly replacing components can be costly, time-consuming, and may not resolve the underlying problem if it lies in software, configuration, or network traffic patterns. This approach bypasses critical diagnostic steps and can lead to unnecessary expenditure and downtime. It fails to adhere to a logical troubleshooting process and can be seen as a failure to exercise due diligence. A professional reasoning process for such situations involves: 1. Clearly defining the observed symptoms and their impact. 2. Gathering all available data from monitoring tools, logs, and user reports. 3. Formulating hypotheses based on the data, starting with the most probable causes. 4. Prioritizing troubleshooting steps based on these hypotheses, focusing on non-disruptive diagnostics first. 5. Implementing changes methodically, with clear rollback plans and change control procedures. 6. Documenting all steps taken and their outcomes. This structured approach ensures that decisions are informed, actions are controlled, and the root cause is identified and resolved efficiently and effectively. Question 10. Regulatory review indicates a critical application hosted in the data center is experiencing intermittent and severe performance degradation. Users report slow response times and frequent timeouts. As a senior network engineer, you are tasked with troubleshooting this issue. Which of the following approaches is the most effective and professionally responsible for initiating the troubleshooting process? Option A. Review recent network configuration changes for any potential misconfigurations that might be impacting traffic flow. Option B. Start by verifying the physical connectivity and link status of all network devices in the path between the users and the application servers. Option C. Consult with the application development team to determine if recent code changes could be the cause. Option D. Immediately begin analyzing application logs and server performance metrics for anomalies. The correct answer is D. Immediately begin analyzing application logs and server performance metrics for anomalies. Explanation. This scenario presents a common challenge in data center operations, a critical network performance degradation impacting business operations. The professional challenge lies in rapidly diagnosing the root cause while adhering to strict operational procedures and potential regulatory compliance requirements, even if not explicitly stated in the question's context, as a general principle of responsible IT management. The need for a structured, evidence-based approach is paramount to avoid misdiagnosis, unnecessary downtime, and potential financial or reputational damage. The correct approach represents best professional practice because it prioritizes a systematic, layered troubleshooting methodology. This aligns with industry best practices for network troubleshooting, emphasizing the OSI model or a similar logical progression. By starting with the physical layer and progressively moving up the stack, engineers can efficiently isolate the problem domain, reducing the scope of investigation. This methodical approach minimizes the risk of overlooking fundamental issues and ensures that more complex, higher-level problems are only investigated after simpler, more common causes have been ruled out. This is ethically sound as it aims for the most efficient and effective resolution, minimizing disruption to services. An incorrect approach that immediately jumps to complex configuration changes without verifying the foundational layers is professionally unacceptable. This could lead to further instability, introduce new issues, and waste valuable time and resources. It fails to adhere to a logical troubleshooting process, potentially violating implicit service level agreements, SLAs, by prolonging downtime. Another incorrect approach, such as relying solely on anecdotal evidence or gut feeling without empirical data, is also professionally unsound. This lacks objectivity, is prone to bias, and can lead to incorrect conclusions, ultimately delaying resolution and potentially causing more harm. It bypasses the need for verifiable evidence, which is a cornerstone of professional IT practice. Professionals should employ a decision-making framework that begins with understanding the reported symptoms and their impact. This is followed by forming hypotheses about potential causes, prioritizing them based on likelihood and impact, and then systematically testing these hypotheses using appropriate tools and methodologies. The process involves gathering data, analyzing it, implementing corrective actions, and verifying the resolution. This iterative cycle ensures that troubleshooting is efficient, effective, and minimizes risk. Question 11. Stakeholder feedback indicates that users are experiencing intermittent packet loss, impacting a critical financial trading application hosted in the data center. The issue appears to be random and not tied to specific times of day or user activity. Network monitoring shows no widespread outages, but individual transaction failures are being reported. What is the most effective initial troubleshooting approach to diagnose the root cause of this intermittent packet loss? Option A. Immediately initiate a full hardware diagnostic sweep on all network devices in the path between the application servers and the end users, and prepare for potential component replacement. Option B. Implement broad, unverified configuration changes on the core and distribution switches, such as adjusting CoS policies or reconfiguring routing protocols, to see if any change resolves the intermittent issue. Option C. Focus exclusively on reviewing application logs and performance metrics for any signs of application-level errors or resource contention that could be misinterpreted as network packet loss. Option D. Analyze interface statistics on the affected application servers and the upstream switch ports for errors, discards, and utilization. Simultaneously, examine flow data, netflow/sflow, from the relevant network segments to identify any traffic anomalies or congestion patterns affecting the application's communication paths. The correct answer is D. Analyze interface statistics on the affected application servers and the upstream switch ports for errors, discards, and utilization. Simultaneously, examine flow data, netflow/sflow, from the relevant network segments to identify any traffic anomalies or congestion patterns affecting the application's communication paths. Explanation. Scenario analysis. This scenario presents a common but challenging implementation issue in data center infrastructure: intermittent packet loss affecting critical application performance. The challenge lies in the distributed nature of data center networks, the complexity of modern network devices, and the potential for multiple contributing factors. Stakeholder frustration due to application unreliability necessitates a swift and accurate resolution, but the intermittent nature of the problem makes it difficult to reproduce and diagnose. The pressure to restore service quickly, coupled with the potential impact on business operations, requires a systematic and evidence-based troubleshooting approach. Correct approach analysis. The correct approach involves a methodical investigation starting with the most probable causes and progressively moving to more complex ones. This aligns with best professional practices for network troubleshooting, emphasizing a structured methodology to isolate the root cause efficiently. By examining interface statistics for errors and discards on the affected servers and the upstream switch ports, the engineer is directly looking for physical layer or congestion-related issues. Analyzing flow data, netflow/sflow, provides visibility into traffic patterns and can reveal anomalies like asymmetric routing or unexpected traffic volumes that might lead to packet drops. Correlating these findings with application logs helps pinpoint if the packet loss is impacting specific application flows. This systematic, evidence-driven approach minimizes downtime and ensures that the resolution addresses the actual problem, thereby upholding professional responsibility to maintain service availability and integrity. Incorrect approaches analysis. One incorrect approach is to immediately assume a hardware failure and initiate a costly and time-consuming hardware replacement without sufficient evidence. This bypasses crucial diagnostic steps and could lead to unnecessary expenditure and extended downtime if the issue is software-related or configuration-based. Ethically, this approach fails to exercise due diligence and could be seen as negligent if proper troubleshooting steps were not taken. Another incorrect approach is to focus solely on the application layer without considering the underlying network infrastructure. While application logs are important, packet loss often originates at the network layer or below. Ignoring network diagnostics means missing potential causes like faulty cabling, misconfigured VLAN, or buffer overflows on network devices. This failure to investigate the full stack is a professional lapse that can lead to prolonged outages and damage to the organization's reputation. A third incorrect approach is to make broad, unverified configuration changes across multiple devices in an attempt to fix the problem. This is a highly risky strategy that can introduce new, more severe problems and make subsequent troubleshooting exponentially more difficult. It demonstrates a lack of systematic problem solving and a disregard for the potential impact of changes, which is a significant ethical and professional failing. Professional reasoning. Professionals facing such issues should employ a structured troubleshooting methodology. This typically involves 1. Understanding the problem. Gather detailed information from stakeholders about the symptoms, affected applications, and timing. 2. Establishing a theory of probable cause. Based on the initial information, form hypotheses about potential root causes. 3. Testing the theory to determine the cause. Systematically test each hypothesis using appropriate tools and techniques, starting with the simplest and most likely causes. 4. Establishing a plan of action to resolve the problem and implement the solution. Once the cause is identified, plan and execute the fix. 5. Verifying full system functionality and implementing preventative measures. Ensure the problem is resolved and take steps to prevent recurrence. 6. Documenting findings, actions, and outcomes. Maintain records for future reference and knowledge sharing. This methodical approach ensures efficient problem resolution, minimizes disruption, and upholds professional standards of competence and responsibility. Question 12. The monitoring system demonstrates intermittent packet loss and increased latency on the core data center network fabric, impacting several critical applications. The issue appears to be sporadic, with no clear pattern of occurrence or specific time of day. Network engineers have observed these symptoms for the past 48 hours. Which of the following troubleshooting approaches is the most appropriate and professional course of action to identify and resolve the root cause? Option A. Focus exclusively on application server logs and performance counters, assuming the network infrastructure is functioning optimally, and the issue must lie within the application layer. Option B. Proceed with a complete reconfiguration of the network fabric, including updating firmware and resetting configurations to default settings, to eliminate any potential software-related issues. Option C. Immediately initiate a series of random reboots of core network switches and routers in an attempt to clear any transient states that might be causing the performance degradation. Option D. Analyze historical network performance metrics, traffic flow data, and device health logs, CPU, memory, interface statistics, for anomalies that correlate with the reported symptoms, while also examining the configuration of affected network segments for recent changes or potential misconfigurations. The correct answer is D. Analyze historical network performance metrics, traffic flow data, and device health logs, CPU, memory, interface statistics, for anomalies that correlate with the reported symptoms, while also examining the configuration of affected network segments for recent changes or potential misconfigurations. Explanation. This scenario presents a common yet challenging situation in data center operations. Intermittent, difficult to diagnose performance degradation. The professional challenge lies in isolating the root cause of packet loss and latency spikes without disrupting critical services or making assumptions that could lead to further instability. The need for a systematic, data-driven approach is paramount, especially in a regulated environment where service availability and data integrity are often mandated. The correct approach emphasizes a methodical investigation, starting with the most probable causes and progressively delving deeper. This aligns with best professional practices by minimizing risk and ensuring that troubleshooting steps are logical and efficient. By examining network telemetry, traffic patterns, and device health, a technician can build a comprehensive understanding of the issue. This systematic process is crucial for meeting regulatory requirements related to service-level agreements, SLAs, and operational resilience. For instance, in the U.S., regulations like those from NIST, National Institute of Standards and Technology, and industry best practices often mandate documented troubleshooting procedures and evidence of due diligence in maintaining system performance and security. An incorrect approach that immediately jumps to reconfiguring network devices without sufficient data is professionally unacceptable. This could violate ethical guidelines by introducing unnecessary risk and potentially exacerbating the problem. From a regulatory standpoint, such an action could be seen as a failure to adhere to change management protocols and a lack of due diligence in diagnosing the issue, potentially leading to breaches of SLAs or compliance failures if the service is deemed unavailable or degraded beyond acceptable limits. Another incorrect approach, focusing solely on application-level logs without considering the underlying network infrastructure, is also flawed. While application issues can cause performance problems, ignoring network telemetry means missing potential network bottlenecks, congestion, or hardware failures that are directly within the scope of data center infrastructure troubleshooting. This oversight could lead to prolonged downtime and a failure to meet operational objectives, which in turn could have regulatory implications if specific uptime or performance metrics are mandated. A third incorrect approach, involving a shotgun method of randomly rebooting network components, is highly unprofessional and risky. This approach lacks any analytical basis and can lead to cascading failures or data corruption. It demonstrates a clear failure to follow established troubleshooting methodologies and a disregard for the potential impact on services. Ethically, it represents a lack of competence and a failure to protect the integrity of the operational environment. Regulatory bodies would likely view such actions as a severe dereliction of duty, potentially leading to penalties if service disruptions occur as a result. The professional decision-making process for similar situations should involve 1. Understanding the scope and impact of the issue. 2. Gathering all available telemetry and logs from monitoring systems. 3. Formulating hypotheses based on the data. 4. Prioritizing troubleshooting steps based on risk and probability. 5. Documenting all actions and findings. 6. Escalating when necessary, providing clear and concise information. 7. Adhering to change management procedures for any modifications. Question 13. Implementation of a new security patch on a critical data center switch is being considered following the discovery of a zero-day vulnerability. The operations team has identified the patch and is ready to deploy it immediately to mitigate the risk. However, the security team has not yet completed a formal risk assessment to evaluate the potential impact of the patch itself on existing services and the likelihood of unintended consequences. Which of the following represents the most professionally sound approach to managing the situation? Option A. Proceed with the patch deployment, but document the decision to bypass the formal risk assessment due to the urgency of the zero-day vulnerability. Option B. Deploy the patch immediately as the zero-day vulnerability poses a greater and more immediate risk than any potential impact from the patch. Option C. Delay the patch deployment until a comprehensive, multi-week risk assessment is completed to ensure no service disruptions occur. Option D. Conduct a rapid, focused risk assessment to identify immediate threats and potential impacts of the patch, and use this to inform the deployment strategy, including rollback plans. Correct answer is D. Conduct a rapid, focused risk assessment to identify immediate threats and potential impacts of the patch, and use this to inform the deployment strategy, including rollback plans. Explanation. This scenario presents a common challenge in data center operations, balancing the need for rapid incident response with the imperative to maintain a secure and compliant environment. The professional challenge lies in the inherent tension between speed and thoroughness. A hasty response, while seemingly efficient in the short term, can lead to overlooked vulnerabilities, incomplete remediation, and potential regulatory noncompliance. Conversely, an overly cautious approach can prolong downtime and impact business operations. Careful judgment is required to navigate this balance, ensuring that all actions are documented, justified, and aligned with established risk management frameworks. The correct approach represents best professional practice because it prioritizes a structured and documented risk assessment before implementing any remediation. This aligns with general IT governance principles, and within a U.S. regulatory context, is fundamental to compliance frameworks like NIST SB 800-53, which mandates risk assessment as a foundational control for security and privacy. By identifying potential impacts and likelihoods, the team can make informed decisions about the scope and urgency of remediation, ensuring that resources are allocated effectively and that the chosen solution does not introduce new risks. This methodical approach also provides an auditable trail, crucial for demonstrating due diligence to regulatory bodies. An incorrect approach that bypasses a formal risk assessment and proceeds directly to implementing a fix without understanding the full implications is professionally unacceptable. This failure can lead to regulatory violations. For instance, under HIPAA, covered entities are required to implement reasonable and appropriate security measures, which implicitly includes understanding the risks associated with any security incident and its remediation. Implementing a fix without a risk assessment could result in a breach of protected health information. 5. If the fix is inadequate or introduces new vulnerabilities, leading to significant fines and reputational damage. Similarly, a failure to document the risk assessment process could be seen as a lack of due diligence during an audit, potentially violating Sarbanes-Oxley (SOX) requirements for internal controls over financial reporting if the data center infrastructure supports financial systems. Another incorrect approach, which involves delaying remediation to conduct an exhaustive, multi-week risk assessment, is also professionally unsound. While thoroughness is important, excessive delay can exacerbate the impact of an incident, leading to prolonged service disruption and potential data loss. This can violate service-level agreements, SLAs, and in regulated industries may constitute a failure to act with reasonable diligence to protect sensitive data, potentially incurring penalties under various data privacy laws. The professional reasoning process should involve a rapid, yet structured, initial risk assessment to inform immediate actions, followed by a more detailed assessment if necessary, all while maintaining clear communication and documentation. Professionals should always consider the principle of least privilege and the potential for unintended consequences when making decisions, especially under pressure. Question 14. Market research demonstrates that intermittent network performance degradation in data centers is a significant challenge for IT operations teams. A critical application hosted within the data center is experiencing random slowdowns, with users reporting occasional unresponsiveness. Initial checks of application logs show no clear errors, and basic server health metrics appear normal. Network monitoring tools show occasional spikes in latency and packet loss on specific interswitch links, but these are not consistently present and disappear quickly. The IT team needs to identify and resolve the root cause of this performance issue. Which of the following troubleshooting approaches is the most professional and effective for addressing this scenario? Option A. Immediately begin reconfiguring quality of service. CO-S policies on all core switches and routers to prioritize the affected application's traffic, assuming congestion is the primary driver. Option B. Focus exclusively on optimizing the application's code and database queries, as application-level issues are often the root cause of perceived network performance problems. Option C. Systematically investigate the network infrastructure layer by layer, starting with physical connectivity and link status, then examining interface statistics for errors and discards, followed by analyzing routing tables and spanning tree states, and finally reviewing traffic patterns and potential bottlenecks using packet captures if necessary. Option D. Roll back recent configuration changes made to the server operating systems and firewalls, as these are the most likely culprits for performance degradation, even without direct evidence linking them to the network symptoms. The correct answer is A. Immediately begin reconfiguring quality of service, CO-S policies on all core switches and routers to prioritize the affected application's traffic, assuming congestion is the primary driver. Explanation. Scenario analysis. This scenario presents a common but challenging situation in data center operations. Intermittent, difficult to produce network performance degradation. The challenge lies in the elusive nature of the problem, which can be exacerbated by a lack of clear initial symptoms and the potential for multiple contributing factors across different layers of the infrastructure. The pressure to restore full performance quickly, coupled with the risk of impacting critical business operations, demands a systematic and well-documented troubleshooting approach. The absence of immediate, obvious errors necessitates a deeper dive into performance metrics and configuration analysis, making it difficult to pinpoint the root cause without a structured methodology. Correct approach analysis. The correct approach involves a methodical, layered investigation, starting with the most likely culprits and progressively moving to more complex or less probable causes. This aligns with industry best practices for network troubleshooting, such as the OSI model or TCP/IP model, which provide a logical framework for isolating issues. By first examining physical connectivity, then link layer issues, and subsequently moving up the stack to network and transport layers, engineers can efficiently rule out common problems. Documenting each step, observation, and change is crucial for reproducibility, collaboration, and post-incident analysis. This systematic process minimizes the risk of introducing new problems while attempting to fix the existing one, and ensures that all potential causes are considered. This approach is best professional practice as it is efficient, effective, and minimizes disruption. Incorrect approach is analysis. One incorrect approach involves immediately making broad configuration changes across multiple network devices without a clear hypothesis or baseline. This is professionally unacceptable because it lacks a systematic basis, increases the risk of unintended consequences, and makes it harder to identify which change resolved the issue, or if it was resolved at all. It violates the principle of controlled troubleshooting and can lead to a more complex and unstable environment. Another incorrect approach is to focus solely on application-level logs without considering the underlying network infrastructure. While application logs can provide valuable clues, network performance issues often stem from network device misconfigurations, congestion, or hardware faults. Ignoring the network layer is a failure to conduct a comprehensive investigation and can lead to wasted time and resources chasing the wrong problem. This approach is professionally deficient as it fails to consider the full scope of potential causes. A third incorrect approach is to rely on anecdotal evidence or the opinions of other team members without verifying the information through direct observation and data collection. While collaboration is important, troubleshooting requires objective data. Acting on unverified information can lead to incorrect assumptions and misguided troubleshooting efforts, which is unprofessional and inefficient. Professional reasoning. Professionals should approach such problems by first gathering all available information, including user reports, monitoring data, and recent changes. They should then formulate a hypothesis based on this information and the known behavior of the data center infrastructure. The troubleshooting process should then proceed in a structured, layered manner, documenting each step and its outcome. If a hypothesis is disproven, a new one should be formed based on the new data. This iterative process, combined with clear communication and documentation, ensures that the root cause is identified efficiently and effectively, minimizing downtime and risk. Question 15. The audit findings indicate that several critical servers are experiencing intermittent packet loss, leading to application timeouts and user complaints. The network infrastructure includes Cisco Nexus switches, Cisco UCS servers, and various SAN components. The troubleshooting team has been unable to consistently reproduce the issue. What is the most appropriate initial troubleshooting approach to identify the root cause of this intermittent packet loss? Option A. Analyze network traffic captures on the affected server interfaces and core switch uplinks, correlating with server-side performance metrics and system logs to identify patterns of packet drops. Option B. Reconfigure the quality of service (QoS) policies on the affected VLAN, assuming that traffic prioritization is causing congestion and packet drops. Option C. Immediately initiate a firmware upgrade on all Cisco Nexus switches in the data path, as outdated firmware is a common cause of performance degradation. Option D. Replace all network interface cards (NIC) on the affected servers, as hardware failure is the most probable cause of intermittent connectivity issues. The correct answer is A. Analyze network traffic captures on the affected server interfaces and core switch uplinks, correlating with server-side performance metrics and system logs to identify patterns of packet drops. Explanation. The audit findings indicate a recurring pattern of intermittent network connectivity issues within the data center, impacting critical business applications. This scenario is professionally challenging because the intermittent nature of the problem makes it difficult to reproduce and diagnose, potentially leading to prolonged downtime and significant financial losses. The pressure to restore service quickly must be balanced with the need for thorough, systematic troubleshooting to prevent recurrence. Adherence to established troubleshooting methodologies and documentation is paramount, especially in a regulated environment where audit trails and compliance are critical. The correct approach involves a systematic, layered troubleshooting methodology, starting with the physical layer and progressing upwards through the OSI model. This ensures that fundamental issues are ruled out before moving to more complex configurations. Documenting each step, observation, and change made is crucial for compliance, knowledge sharing, and future reference. This aligns with best practices for IT service management and operational excellence, ensuring that solutions are not only effective, but also sustainable and auditable. An incorrect approach would be to immediately jump to complex configuration changes or software updates without verifying the physical infrastructure. This could lead to misdiagnosis, wasted effort, and potentially introduce new problems. For example, assuming a routing issue without checking cable integrity or port status is a failure to follow a logical troubleshooting process. Another incorrect approach is to make changes without proper documentation or rollback plans. This violates principles of change management and auditability, making it impossible to track the root cause or revert if the change exacerbates the problem. Furthermore, relying solely on anecdotal evidence or gut feeling, rather than data-driven analysis and established procedures is unprofessional and increases the risk of error. Professionals should employ a structured decision-making process that prioritizes data collection, hypothesis generation, testing, and validation. This involves understanding the scope of the problem, identifying potential causes based on symptoms, and systematically testing each hypothesis. When faced with intermittent issues, leveraging monitoring tools, logs, and historical data becomes even more critical. Collaboration with other teams and escalation when necessary are also key components of effective problem solving. Question 16. Compliance review shows that critical data center application experienced intermittent connectivity issues, leading to user complaints. Initial troubleshooting involved a quick restart of the application server, which temporarily resolved the problem. However, the underlying cause remains unknown, and the network engineer is considering whether to proceed with a deeper investigation or consider the issue closed since the immediate symptom is gone. Option A. Close the incident ticket as resolved, assuming the server restart addressed a transient network glitch, and focus on other pending tasks. Option B. Escalate the issue to a higher-tier support team without performing any further investigation, as the problem is intermittent and complex. Option C. Conduct a comprehensive root cause analysis by examining application logs, server event logs, network traffic captures, and recent configuration changes to identify the specific vulnerability or misconfiguration that led to the connectivity issues. Option D. Implement a broad security patch across all servers in the data center as a precautionary measure, without specifically identifying the exploit. The correct answer is C. Conduct a comprehensive root cause analysis by examining application logs, server event logs, network traffic captures, and recent configuration changes to identify the specific vulnerability or misconfiguration that led to the connectivity issues. Explanation. This scenario presents a common challenge in data center operations, ensuring the integrity and availability of critical infrastructure while adhering to strict compliance mandates. The professional challenge lies in balancing the immediate need for troubleshooting and resolution with the long-term implications of security vulnerabilities and potential data breaches. A rushed or incomplete troubleshooting process, even if it resolves the immediate issue, can leave the data center exposed to further attacks or regulatory penalties. A correct approach, which involves a systematic and documented investigation of the root cause, is best professional practice because it directly addresses the underlying security weakness. This aligns with the principles of robust cybersecurity and data protection, which are often codified in regulatory frameworks. By thoroughly analyzing logs, traffic patterns, and configuration changes, the network engineer can identify the specific vulnerability exploited, implement a permanent fix, and update security policies to prevent recurrence. This proactive stance minimizes future risks and demonstrates due diligence in protecting sensitive data, a key requirement for compliance. An incorrect approach that bypasses thorough analysis for a quick fix, such as simply restarting a service or reverting to a previous configuration without understanding the exploit, is professionally unacceptable. This failure to identify the root cause leaves the system vulnerable to the same or similar attacks. From a regulatory perspective, this could be considered negligence, especially if the exploited vulnerability is a known one. It fails to meet the standard of care expected in managing critical infrastructure and protecting sensitive information. Another incorrect approach, such as ignoring the incident because it did not result in immediate data loss, is also a significant ethical and regulatory failure. The absence of immediate, observable damage does not negate the presence of a security breach or the potential for future compromise. This demonstrates a lack of proactive security posture and a disregard for the potential impact on data confidentiality, integrity, and availability. Professionals should employ a decision-making framework that prioritizes a structured, evidence-based approach to troubleshooting. This involves 1. Incident identification and containment. Immediately isolate the affected systems to prevent further spread. 2. Evidence gathering. Collect all relevant logs, configuration data, and network traffic. 3. Root cause analysis. Systematically analyze the gathered evidence to determine the exact cause of the incident. 4. Remediation. Implement a solution that addresses the root cause, not just the symptoms. 5. Verification. Test the solution to ensure it has resolved the issue and not introduced new problems. 6. Documentation and reporting. Record all steps taken, findings, and resolutions for future reference and compliance audits. 7. Post-incident review. Analyze the incident to identify lessons learned and improve security policies and procedures. Question 17. Investigation of a critical performance degradation impacting customer-facing services reveals that the root cause may lie within network traffic containing sensitive customer financial data. The network engineer, under pressure to restore service immediately, considers directly accessing and analyzing packet captures containing this sensitive information to identify the bottleneck. Option A. Proceed with troubleshooting the network performance issue without directly examining the packet captures, relying solely on network device logs and metrics. Option B. Escalate the issue to the information security team, requesting their assistance in analyzing the packet captures through a controlled and authorized process. Option C. Attempt to anonymize or mask the sensitive customer financial data within the packet captures on the fly before analysis. Option D. Directly access and analyze the packet captures containing sensitive customer financial data to expedite the troubleshooting process. The correct answer is D. Directly access and analyze the packet captures containing sensitive customer financial data to expedite the troubleshooting process. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the ethical obligation to maintain data integrity and confidentiality, particularly within a regulated industry like financial services. The pressure to quickly resolve a performance issue, coupled with the potential for significant financial impact, creates a temptation to bypass established procedures. The core of the challenge lies in balancing the urgency of the business need with the imperative to adhere to data privacy regulations and internal security policies. The network engineer must exercise sound judgment to avoid actions that could lead to unauthorized data access or disclosure, which carry severe legal and reputational consequences. Correct approach analysis. The correct approach prioritizes adherence to established data handling and security protocols, even under pressure. This aligns with the principles of data protection and privacy mandated by regulations such as the General Data Protection Regulation, GDPR, or similar frameworks governing data handling in the U.S., depending on the exam's specified jurisdiction. Specifically, it upholds the principle of least privilege and the requirement for explicit authorization before accessing sensitive information. By escalating the issue to the security team and requesting a controlled, authorized access method, the engineer ensures that any investigation into the performance issue is conducted in a manner that respects data privacy and complies with regulatory requirements. This proactive and compliant approach prevents potential data breaches and avoids violations of data protection laws, safeguarding both the organization and its customers. Incorrect approach is analysis. Accessing the sensitive customer data directly without proper authorization, even with the intent to troubleshoot, constitutes a serious breach of data privacy regulations and internal security policies. This action violates principles of data minimization and purpose limitation, as the data is accessed for performance troubleshooting, beyond its original collection intent, without explicit consent or a legitimate, authorized basis. Such an action could lead to significant fines and legal repercussions under data protection laws. Attempting to anonymize or mask the data on the fly during troubleshooting is also problematic. While the intention might be to reduce risk, it still involves unauthorized access and manipulation of sensitive data. Furthermore, the effectiveness of on-the-fly anonymization can be questionable, and it does not absolve the individual of the initial unauthorized access. This approach bypasses established, tested, and approved data sanitization procedures, introducing a risk of incomplete anonymization or accidental re-identification. Ignoring the data privacy implications and proceeding with troubleshooting without considering the sensitive nature of the data is a direct violation of ethical responsibilities and regulatory mandates. This demonstrates a lack of due diligence and a disregard for the potential harm that unauthorized access or disclosure of sensitive information can cause to individuals and the organization. It fails to uphold the duty of care expected of IT professionals in handling protected data. Professional reasoning. In situations involving potential data privacy concerns during troubleshooting, professionals should follow a structured decision-making process. 1. Identify and assess risk. Recognize the sensitive nature of the data involved and the potential regulatory and ethical implications of accessing it. 2. Consult policies and procedures. Refer to internal security policies, data handling guidelines, and relevant regulatory frameworks. 3. Escalate and seek authorization. If direct access or investigation of sensitive data is required, escalate the issue to the appropriate security or compliance team and obtain explicit, documented authorization for the specific actions to be taken. 4. Utilize approved tools and methods. Employ only authorized tools and methodologies for data access and analysis, ensuring they are compliant with privacy regulations. 5. Document all actions. Maintain a detailed record of all troubleshooting steps, data accessed, and decisions made. This systematic approach ensures that urgent operational needs are met without compromising data security, privacy, or regulatory compliance. Question 18. What factors determine the appropriate level of regulatory compliance review for changes to Cisco data center infrastructure, considering potential impacts on data privacy and security? Option A. the historical success rate of similar network changes, and the general IT security posture of the organization. Option B, the vendor recommendations for the Cisco hardware and software being modified, and the current operational performance metrics. Option C, the perceived urgency of the network change and the availability of internal IT resources for implementation. Option D, the specific industry sector the data center serves, the sensitivity of the data processed, and the applicable data protection regulations. The correct answer is D, the specific industry sector the data center serves, the sensitivity of the data processed, and the applicable data protection regulations. Explanation: the scenario presents a common challenge in data center operations, ensuring that network infrastructure changes comply with evolving regulatory requirements, specifically those related to data privacy and security. The professional challenge lies in balancing the need for operational agility and performance improvements with the imperative to maintain regulatory adherence. Misinterpreting or overlooking these requirements can lead to significant legal penalties, reputational damage, and loss of customer trust. The correct approach emphasizes a proactive and integrated strategy for regulatory compliance. This involves embedding compliance checks into the change management process, utilizing automated tools for validation, and maintaining comprehensive documentation. This represents best professional practice because it aligns with the principles of due diligence and risk management mandated by regulatory frameworks. Specifically, it addresses the need for organizations to demonstrate a robust control environment that protects sensitive data and ensures operational integrity, as often required by regulations like GDPR, if applicable to the exam's jurisdiction. Otherwise, adapt to the specified jurisdiction's equivalent. Maintaining up-to-date knowledge of relevant regulations and their implications for network infrastructure is paramount. Incorrect approaches fail to adequately address the regulatory landscape. One incorrect approach might involve prioritizing speed of deployment over thorough compliance review. This is a regulatory failure because it bypasses necessary checks and balances, increasing the risk of non-compliance and potential data breaches. It demonstrates a lack of due diligence and a disregard for the legal obligations of data protection. Another incorrect approach could be relying solely on manual, ad hoc compliance checks. This is ethically and regulatorily problematic as it is prone to human error, inconsistency, and is difficult to audit. It fails to establish a repeatable and verifiable process for ensuring compliance, which is a fundamental expectation of regulatory bodies. A third incorrect approach might be to assume that existing compliance measures are sufficient without periodic reevaluation. This is a failure of ongoing vigilance and risk management. Regulations change, and so do the threats and vulnerabilities. Without continuous assessment, an organization can inadvertently fall out of compliance, leading to severe consequences. The professional decision-making process for similar situations should involve a structured approach to change management that explicitly incorporates regulatory compliance. This includes 1. Identifying all applicable regulations and their specific requirements related to the proposed change. 2. Assessing the potential impact of the change on compliance status. 3. Developing and implementing mitigation strategies to address any identified compliance gaps. 4. Documenting all compliance-related activities and decisions. 5. Establishing a process for ongoing monitoring and auditing of compliance. This systematic approach ensures that regulatory considerations are not an afterthought, but are integral to the entire life cycle of infrastructure changes. Question 19. When evaluating the performance of a Cisco data center infrastructure and identifying areas for process optimization and troubleshooting, which of the following approaches best aligns with established best practices for ensuring operational stability and efficiency? Option A. Focus exclusively on applying quick fixes to symptoms as they arise, without investigating the underlying systemic causes of performance issues. Option B. Immediately implement changes to network device configurations based on the most recent high-profile incident reported by users, without prior baseline analysis. Option C. Prioritize optimization efforts based on the perceived visibility of the fix to stakeholders, rather than on a data-driven analysis of performance bottlenecks. Option D. Establish clear performance baselines for key infrastructure components and systematically analyze deviations from these baselines to identify root causes for performance degradation. The correct answer is D. Establish clear performance baselines for key infrastructure components and systematically analyze deviations from these baselines to identify root causes for performance degradation. Explanation. Scenario analysis. This scenario presents a common challenge in data center operations, optimizing performance under the constraint of limited resources and evolving business demands. The professional challenge lies in balancing immediate operational needs with long-term strategic goals, ensuring that troubleshooting efforts are not only effective in resolving current issues, but also contribute to a more resilient and efficient infrastructure. The pressure to minimize downtime and maintain service-level agreements, SLAs, adds a layer of urgency, requiring a systematic and well-justified approach to process improvement. Correct approach analysis. The correct approach focuses on establishing baseline performance metrics and then systematically analyzing deviations. This aligns with best practices in IT service management and operational excellence, often implicitly or explicitly supported by industry standards and regulatory frameworks that emphasize proactive monitoring, root cause analysis, and continuous improvement. By defining what normal looks like, anomalies become immediately apparent, allowing for targeted troubleshooting. Documenting these baselines and the troubleshooting process itself is crucial for knowledge transfer, audit trails, and future problem resolution, contributing to overall operational integrity and compliance. This methodical approach minimizes the risk of introducing new issues while attempting to fix existing ones, and ensures that resources are allocated efficiently. Incorrect approaches analysis. One incorrect approach involves immediately implementing changes based on anecdotal evidence or the most recent high-profile incident. This is professionally unacceptable because it bypasses the critical step of establishing a baseline and understanding the true impact of the change. It risks introducing unintended consequences, exacerbating existing problems, or failing to address the root cause, potentially leading to breaches of SLAs or even regulatory noncompliance if the changes negatively affect data integrity or availability. Another incorrect approach is to focus solely on reactive fixes, without any attempt to understand the underlying systemic issues. This is professionally unsound, as it leads to a cycle of recurring problems, increased operational costs, and diminished system reliability. It fails to meet the professional obligation to build and maintain robust systems, and can be seen as a dereliction of duty if it leads to persistent performance degradation or security vulnerabilities, which could have regulatory implications depending on the data handled. A third incorrect approach might be to prioritize changes that offer the most visible or immediate impact, even if they are not the most critical or root cause related. This is professionally problematic because it can lead to misallocation of resources and a failure to address the most significant performance bottlenecks or risks. It prioritizes short-term perception over long-term stability and efficiency, potentially violating principles of due diligence and responsible system management. Professional reasoning. Professionals should adopt a structured problem-solving methodology. This begins with clearly defining the problem and its scope. Next, gather relevant data, including performance metrics, logs, and configuration details. Establish or review existing performance baselines to understand normal operating parameters. Formulate hypotheses about the root cause and test them systematically. Implement solutions in a controlled manner, ideally in a staging environment first, and monitor their impact closely. Document all steps, findings, and resolutions. For process optimization, this involves not just fixing immediate issues, but also analyzing trends, identifying recurring problems, and implementing preventative measures or architectural improvements. This systematic, data-driven, and documented approach ensures accountability, promotes efficiency, and upholds professional standards of care in managing critical infrastructure. Question 20. Quality control measures reveal that a proposed network configuration update in the data center, intended to improve interVLAN routing performance, has not undergone a formal risk assessment process. The operations team is eager to deploy the change to address user complaints about latency. What is the most appropriate course of action to ensure the integrity and stability of the data center infrastructure? Option A. Implement the configuration update during a low-traffic period and rely on the team's collective experience to identify and resolve any issues that arise. Option B. Deploy the configuration update to a small subset of the network as a pilot test, and if no immediate issues are observed, proceed with a full rollout. Option C. Proceed with the configuration update immediately to address user complaints, and monitor performance closely for any adverse effects. Option D. Halt the deployment of the configuration update until a comprehensive risk assessment is completed, including potential impacts on security, availability, and other critical services. The correct answer is C. Proceed with the configuration update immediately to address user complaints, and monitor performance closely for any adverse effects. Explanation: this scenario presents a professional challenge due to the inherent tension between maintaining operational uptime and the need to proactively identify and mitigate potential risks within a critical data center infrastructure. The pressure to avoid service disruption can lead to a temptation to defer necessary risk assessments, especially when they might require downtime or resource allocation that impacts immediate performance metrics. Careful judgment is required to balance these competing demands, ensuring that the long-term stability and security of the data center are not compromised for short-term gains. The correct approach, which involves conducting a comprehensive risk assessment before implementing significant configuration changes, represents best professional practice. This aligns with the principles of robust IT governance and operational resilience, often mandated by industry standards and regulatory frameworks, though specific regulations are not cited here due to the exam's jurisdictional constraints. The principle of due diligence in risk management is universal. A proactive risk assessment allows for the identification of potential vulnerabilities, the evaluation of their impact, and the development of mitigation strategies. This systematic approach minimizes the likelihood of unforeseen outages, data loss, or security breaches, thereby safeguarding the integrity and availability of the data center services. It demonstrates a commitment to responsible system management and adherence to best practices in change management. An incorrect approach that bypasses or inadequately performs a risk assessment before implementing changes is professionally unacceptable. This failure constitutes a significant ethical and potentially regulatory lapse. It demonstrates a disregard for due diligence and a lack of commitment to the principles of risk management. Such an approach increases the probability of introducing new risks or exacerbating existing ones, leading to potential service degradation, financial losses, and reputational damage. In a regulated environment, this could also lead to noncompliance penalties. Another incorrect approach, focusing solely on immediate performance metrics without considering the underlying risks, is also professionally unsound. This narrow focus ignores the interconnectedness of system components and the potential for seemingly minor configuration changes to have cascading negative effects. It prioritizes short-term gains over long-term stability, which is a hallmark of poor risk management. Finally, an approach that relies on anecdotal evidence or past experience without a formal documented risk assessment is insufficient. While experience is valuable, it cannot replace the systematic and objective analysis provided by a structured risk assessment process. This informal method is prone to bias and may overlook novel or subtle risks that are not immediately apparent. The professional decision-making process for similar situations should involve a structured approach to change management. This includes 1. Clearly defining the proposed change and its objectives. 2. Conducting a thorough risk assessment to identify potential threats, vulnerabilities, and their impacts. 3. Developing and documenting mitigation strategies. 4. Obtaining appropriate approvals based on the risk assessment. 5. Implementing the change during a planned maintenance window with rollback procedures in place. And 6. Performing post-implementation verification and monitoring. This systematic process ensures that changes are made in a controlled and responsible manner, prioritizing the stability and security of the data center infrastructure.